Regal's RSA 5000 series real-time spectrum analyzers with ultra-rail technology improve signal capture, triggering, and visualization for RF design and debug challenges. Today, we'll discuss the key benefits of a real-time spectrum analyzer and demonstrate how these capabilities improve debugging on a variety of RF signals. Let's look at examples of each. First, real-time analyzers enable engineers to find more transient signals the first time they look. The RSA 5000 with 40 MHz of real-time bandwidth comes with 7.45 microsecond, 100% POI, or probability of intercept. Any event lasting longer than this is guaranteed to be captured every time it occurs. Here we are capturing a custom protocol similar to many ISM band signals being designed and debugged in IoT, medical, and consumer products today. Our simple protocol uses multiple channels, in this case 5 channels at 7.5 MHz spacing, centered at 2.4 gig. Each RF transmission consists of an 8 microsecond on time with FM modulation encoding the data. As we test our transmitter operation, we have it set up to cycle through the 5 channels transmitting once per second. Let's pause here for a second. The spectrogram or waterfall chart at the bottom of the screen shows the frequency span across the x-axis, with the latest traces being added to the top and traces below being further back in time. This shows how the carrier is changing over time. We can see it moving across the screen in frequency. The top of the screen is a density plot. This shows many captures of the data together and color codes it for how often the power in that frequency is in that region. Therefore, parts of the trace that are found occasionally, such as these low-duty cycle pulses, appear bluer. Signal levels that are more common would appear warmer, moving up the color bar on the left. The instrument captures every pulse from the transmitter, making it possible to debug the transmitter settings, power levels, and frequency accuracy. To debug further, we may want to trigger on specific transmissions to verify other elements of the design. The first trigger method uses the frequency mask trigger to only capture data when the signal falls within the masked region. Find the root cause of erroneous transmissions or verify the characteristics of critical signals while ignoring other sources that might interfere. Let's pause here. This is the same signal as the previous test. Here, the green area is the mask. As every waveform is analyzed, only ones where the power in a given frequency appears in this area is added to the display. This visualization mode is called normal and simply shows the most recent trace. Here I've added a trace type of max hold to show all the previous captures from the frequency mask trigger. Frequency mask triggering is important because it makes it possible to ignore nearby extraneous signals that aren't of interest and make debugging more difficult. The RSA 5000 can also trigger on the power level. Now let's pause here. Now we have a new view on the bottom. That's the normal plot we're used to. On top, we can now view the signal in the time domain. This is the power in the entire 40 MHz frequency span and how it is modulating over time. We trigger on this change in power to view the modulation in time, even as the carrier changes across the span below. Now we can trigger on power in the time domain, giving engineers one more way to identify the transmission they are looking for, while still seeing it in the context of the entire RF capture. We have seen different methods for visualizing the RF signals in the previous examples, including the density plot, spectrogram, normal trace, and power versus time. The combination views include this, power versus time with normal and spectrogram, as well as the density spectrogram and PVT with normal trace modes we saw earlier. Here we can see the pattern of channel selection change in the spectrogram, while still monitoring the carriers in the normal view and capturing the off gaps between pulses in the time window. This gives us an important view for debugging signals that are dynamic both in frequency and amplitude at the same time. These 7 mixed display modes help us to visualize the signals we can capture and trigger on in new ways with the real-time analysis capabilities of the RSA 5000. 100% probability of capture for fast transient signals, frequency mask and power triggering, and an array of visualization modes all work together to make ultra-real technology and real-time analysis a revolutionary step forward for debugging today's complex RF applications.